Hello and welcome once again to our foray into the world of Pobble Live. I'm just going to give it a minute or two for people to join us. Please say hello in the chat. And while we wait, we'll have a look at what we usually look at the beginning. What wacky combination of tie and cardigan is Mr. Keeling wearing this week? And as you can see, I am sporting a purple cardigan this week with little turquoise triangles along it and a geometric pattern. And if we zoom in on the tie for this week, it appears to be around agriculture. We have farming equipment and sunflowers. There are also some dancing pigs on there as well. So we've got 6 people with us to start with. If you could add a like, if you could subscribe if you haven't already subscribed, that would be really good. Hello to those people joining the chat. Thank you for being here. If you are watching this later, apologies that I didn't go around today and remind you that we were doing Pobble Live. But we were out on a school trip, which was a lot of fun with the year sixes. So we got back at the end of the day. It's nice to see, though, that some of the year sixes are already in the chat saying, hey, please do not add people's names, though, even if you recognize who they are. I will have to remove those comments just because we don't use first names. Now, Pobble this week, slightly different because it's actually not going to focus on our Pobble, right? Instead, we are going to launch a whole school competition. Now, that means there won't be a Pobble winner this week in terms of writing. However, there will be 5 winners for this competition that I'll talk about in just a moment. And also, there will still be the regular Pobble draw for anybody who puts a message into the chat. Let's start by looking at what our Pobble star looks like this week. I've decided to go for goldeny silvery. I think it's more gold than silver. A lovely golden star. Ooh, we had someone say blue. No, wasn't blue this week. Knew it already. There we go. Gold. Yeah, we went for golden star. All right. I'm going to start up today because it's a little bit different to usual. We're still going to talk a little bit in the chat and I'm still going to get some ideas from you. But really, today is all about something that's less rooted in writing and more focused around science. And why not? Because after all, this week is British Science Week. And all across our school, we've been doing science experiments, we've been doing science lessons, and we've been joining in with lots of lovely live science things going on with the BBC. I know in 6, we've watched the BBC live lesson. We've joined a seminar or a Teams meeting all about science. We have done a science experiment in class where we've looked at the ways we can remove microplastics from our ocean. And we have also, or we are going to be looking at the size of all of our children across school to find the median height in each year group. Lots and lots of things there. I'm just going to go back though, because don't want to give it away. Who can tell me, I've just hidden it, you may have read it already, but who can tell me the 3 main branches of science? There are 3 main areas of science. Can anybody in the chat tell me what they are? What are the 3 main areas of science? We've got 1, biology, the study of living things. Absolutely, that is one of the 3 main branches of science. Can anyone tell me the other 2? We have the study of living things, biology. Absolutely, we have chemistry. Looking at how different chemicals react with one another in chemical change, and physics. Absolutely, physics, the things that kind of make up our universe and the things that happen within the rules of our universe, but also theoretical physics, people having theories about how things are formed and how things happen. So there are 3 branches of science: chemistry, biology, and physics. Well done. There they are: chemistry, physics, and biology. They're the main three that we look at. And kind of all science fits with under those umbrella terms. If you want to be a doctor in the future, for example, you may study biology, how the human body works. If you want to create your own theories around the universe, you may want to go into physics. And if you want to be one of those scientists you see in the lab with all the different chemicals and creating new medicines and that kind of thing, you might want to go into chemistry. But we are focusing this week on science because it is our British Science Week. And we've done lots and lots of things that I'm sure will fill our newsletter this Friday. As such, I said that the Pobble this week isn't really Pobble. It's not really a written piece. What we're doing is, across the school, we are launching a poetry competition. And we are going to be choosing 5 winners. So it's not just one winner this week, it is 5 winners. The 5 best posters across our school will be entered in to the British Science Week poster competition with a chance of winning some excellent prizes. Of course, we'll have a celebration for those who win in school, but then they'll be sent off to see if we can win other prizes outside of school. So I'm going to just read this through to you and tell you a little bit more about the competition. Do you know that identical twins don't have the same fingertips? Yeah, we learned a little bit about their genes, didn't we? And they are not identical, but they are closely related. Okay, so competition: create a British Science Week poster. Children aged 3 to 11, that's you, can get creative and enter the British Science Week's annual UK-wide poster competition. To enter, they simply need to create a poster which fits with the theme, and this year's theme for British Science Week is changing and adapting. And we're going to learn a little bit about what changing and adapting is in a little while. Schools then select the 5 best creations and submit them for a chance of winning an array of prizes. The activities found in this pack, don't worry about that. I'm just going to talk about what you can use. So to make this poster, you can use plain A4 paper. If you haven't got any at home, feel free to ask us in school for A4 or A3 paper, and we'll give you some so that you can take and try. But the things that you can use to design your poster, you can use pens, pencils, scissors, glue, watercolors, paint, crayons, pipe cleaners, felt, thread, wool, foil, clay, string, beads, stamp, foam, pom-poms, anything creative really, as long as we can send that off. And even if it is 3D and kind of big or a diorama, we'll take a photo and that might be entered into the competition. So here are the instructions. And then we'll delve a little bit deeper into features of a poster and what change and adaptation is. So encourage children to think about change and adaptation, what it means to them and how it relates to science that they've learned about, to come up with ideas to include in their poster. So really, what we need to delve into is what is the difference between a change and an adaptation, because they are quite closely related. But let's go on and let's talk about that then. So what is change and adaptation? I'm going to have a little chat to you about that, and then we're going to look at examples and see whether or not you think it's a change or an adaptation and which one it relates to, the images that I've got. So British Science Week is taking place between the 7th and the 16th of March 2025. This year's theme explores change and adaptation, which is all around us. For example, animals and plants change and adapt to their surroundings to survive. Who can very quickly think of a change, a complete change that an animal goes through? Because really that's the key difference between change and adaptation. A change is bigger, longer lasting, a complete alteration, whereas an adaptation is a slight change to make sure that you can exist within a certain situation. Yeah. So a change is a complete change. Adaptation is a slight change, a smaller version of that change. Can anybody think of a big change, a complete change that an animal might go through. Certainly, you would change with age, and that is a permanent change. When you age, you don't get younger again. Those changes are permanent. Absolutely. So aging is a change. Well done. Any other that an animal might go through? I always think one of the best ones is, one of the early ones that we learned about, probably in year 1 or year 2, where we would learn about this. What would that have to do with change? That's not an adaptation, that is a change. What happens there? Let me just get a rubber, sorry. If you can understand what my drawing is. There we go. Lovely word there. Metamorphosis. And it is a complete metamorphosis because the caterpillar becomes the butterfly after going into its cocoon. Now, that is a change. It happens within its lifetime. It's not an adaptation. It's not a slight change. Learning to live without family. Well, that would be more of an adaptation, because when you grow up and you do learn to live independently and on your own, it doesn't mean that you can't go back, that you can't go and see family, and that you can't seek support in the future. That's more of adapting. You're not changing form, are you? You're just moving on to the next stage in your life. So that's more of an adaptation than it would be a change. You're adapting to a situation. A seahorse begins with its parents, but then learns to live on its own. Again, that's kind of an adaptation. You're adapting to what has happened. Let's keep going with this. We've also seen technology consistently evolving, which can help people in many different aspects of their lives, from learning in classrooms to finding new medical treatments. And again, technology can change or it can adapt. For example, televisions, they have adapted, I would say, in recent years, but they have also changed. So over the time, they've changed their looks, haven't they? So they've become more like these big, flat black panels that live in our living rooms, like that, big, large, much bigger. So they have changed in size and shape, but they've also adapted to suit the world, haven't they? So not just television anymore, but it also has things like YouTube on there. It has things like Amazon on there. It has internet connectivity. So television is something that's changed, but has also adapted. Phones have certainly changed. They used to be plugged into the wall. Now they are devices, but then they adapt as well. They have new apps, new applications, new things within that same phone. So even though the phone doesn't change necessarily, it can adapt too. TV's changed so much, yeah. We don't have to get up and press the buttons anymore, do we, on the television to change the channel? It doesn't just happen here on Earth. Even the stars and in outer space, objects can change too. Perhaps there is life on other planets that also adapts as their environment changes. Who knows? Another changes that we need to be mindful of is our planet and climate change. How we have to. Our planet is warming up, weather is changing, and because of that, we need to adapt how we live on a planet. So really, the focus of Science Week is vital, because everything that we've done in science involves somewhere in the curriculum change and adaptation. For example, at the moment in my class, we're going on a walk. We're doing the Pobble walk. At the moment in my class, we are learning about electricity. And in electricity, we can change a circuit by removing what is in there, the purpose of that circuit. So maybe, for example, I want to light a light bulb. If I want to light a light bulb, I will have to build one type of circuit. And then if I want to build something for, let's say, a fire alarm to go off, I would have to build a completely different circuit. I would have to change that circuit. I would have to change the components. However, if I want to make the circuit work so that the bulb is brighter, or let's say I'm making a sound in my circuit, I might adapt it, adding more batteries so that it becomes louder. So even within electricity and the subject of electricity, we can have changes and adaptations, and it actually fits along the entire spectrum of science that we have looked at. So let's have a little practice. I'm going to show you a couple of pictures. I want you to tell me if it's a change or an adaptation, and then how, please, if you are in the chat today. So, is this a change or an adaptation? This is, and a lot of you will recognize this, this is states of matter. And in school, we generally teach you about 3, but there's actually 4 states of matter here. So the first state of matter is a solid, and a solid, let's think of it like water, shall we? So we've got water, which is this one here. We've got what it becomes, and we've got it as a solid. So the solid version of water, when we freeze it, is ice. And we can see that the particles, the molecules that make up the ice, are all very tightly packed together. So that means that you find it very difficult to pass through that ice because of all those molecules really, really tightly together. There are very, 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 very minuscule gaps in between them. There are gaps are there, but they're very, 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 very minuscule that you cannot see them. However, when we heat up that ice, it begins to melt. Those particles become looser. They're still harder to pass through than the next stage, but they are looser and you can move through them, and that is a liquid, that is water. I don't know if you've ever tried to run in a swimming pool, but it's harder than just running through the air. That's because even in a liquid, the molecules are still tightly packed together, making it harder to pass through. And then if you heat up that water, those molecules start to vibrate, they start to move faster and find more space, and it turns into a gas. It evaporates, it becomes a gas. At super high temperatures, very, very high temperatures, that can then become something called plasma. But we don't generally teach about that because that's generally something that happens in the stars and in space. So we've got our states of matter. We've got our solid, our liquid, our gas, and our plasma. Is that an adaptation or is that a change? What do we think? Pop it in the chat. Is it something that's adapting slightly to the world around it, but is staying predominantly the same? Or is it something that's completely changed? Obviously, change. Yeah, change. It is a change. It's gone from a solid to a liquid to a gas to plasma. Now, there are 2 types of change. You can have something called a permanent change or an irreversible change, or you can have a non-permanent change or a semi-permanent change, which is a reversible change. There's also other ways of looking at it. So you can have something which is called a physical change, or you can have a chemical change. And if you wanted to do your poster just based around these types of change, I encourage you to research them and find different types. But you can have chemical changes. Those are more likely to be permanent changes, and you can have physical changes. Let me show you a physical change if I can. 1 second. Let me just see if I've got something. Lovely. Here we go. So this is a physical change. You see I have a bit of blue tack here, and I can extend that blue tack. I've changed the blue tack because I've placed a force on it. I've stretched, I've pulled that blue tack, and it has changed physically. However, I can very easily reverse that physical change by putting the blue tack back together. Physical changes like pushing on something, bending, shaping, are generally really easily reversed. A chemical change, you are changing the very molecules that make it up. And because of that, you usually see things like smoke, bubbles, or gas, and it completely metamorphosizes. And generally, chemical changes are permanent. Not always, but mostly are permanent. Let's take toast or cooking, for example. When you cook something, it permanently changes the thing that you have cooked. Unless, of course, you put ice in the oven, that'll be water. You can always freeze it again. But like toast, when it becomes toast, it's completely changed. Dissolving, that's a really good word. Yes, dissolving something into water is a change, but there are certain circumstances where you can get some of the things that are dissolved back. So, for example, if you dissolve salt into water, you can use a process called titration, where you evaporate that water so that it turns into a gas and it leaves the solid salt crystals behind. So you can actually get the salt back. But that is an example of types of change. And if you would like to do a poster on those types of change, I encourage you to do that. You could, if you wanted to, do a poster on the science of cooking, because that is working with changes. Some chefs are like scientists and they work on that level of flavor and change within food, applying heat to create chemical reactions. So if you want a poster on cooking and showing how cooking relates to science, that's something else that you could research. So absolutely, states of change, states of matter are a change. All right, how about this one then? So let me put this into context for you. Giraffes, they live on the plains of Africa, where it can be quite dry. And because it can be quite dry, grass can find it quite difficult to grow. So giraffes would have to eat the leaves from the trees, the tall trees that were around. And what they found was giraffes that had the shorter necks could only eat the leaves that were at the bottom of the trees. Giraffes that had slightly longer necks could eat the leaves higher up, which meant that the giraffes with the longest necks would survive. And that means that their children, when they were born and inherited their genes, they would have slightly longer necks too, which meant that they could eat the higher up leaves. And again, all of these giraffes, they were eating the leaves at the same height, but the ones that were most successful were the giraffes that had the slightly longer necks, because they could eat the food that was higher up. And then the giraffes that had the slightly longer necks could eat the food that was higher up. And the giraffes that had the slightly longer necks could eat the food that's higher up. And over a process of years and years and years, these giraffes have grown their necks so that they can eat the food at the top of the tree. Now, it is the same animal, but over time, their necks have extended to suit their surroundings so that they can get the leaves on the trees. Is that a change, or is that an adaptation? What do we think? It can be both, since animals change because of age or metamorphosis, and they could adapt because of their bodies. So like the ones with the longer necks can eat the higher leaves, if that makes sense. That absolutely does make sense. It's very clear. It's very nice. Absolutely. And I agree. It's an adaptation. I mean, they have changed over the years. The necks got longer, but that's because they're trying to adapt to their environment. They've adapted so that they can reach those leaves. And it's not a radical change. It's not a massive change. It's a slight alteration to that animal so that they can reach those leaves. Now, adaptations generally can happen without a physical change. When we talk about change in science, we're talking more about physical changes or chemical changes where that thing becomes something else. An adaptation can be like this, an actual change where the neck is getting longer. But it can also mean a change in behavior. So adaptation can be how we act in the world around us. And we'll learn a little bit about that very soon, because there's an interesting one I'm going to share with you. Oh, here we go. We already had this example, but does anybody recognize what this is? This is, can anyone remember the book? Anyone remember the book from when you were very small, or maybe you're joining us from year 1 and 2 where you're reading this book, or reception or nursery where they may be reading this book? I'm certainly going to be buying this book for my daughter. Yeah, absolutely. The Very Hungry Caterpillar eats through everything in the book, including the book itself, doesn't it? I'm trying to think of the book, The Very Hungry Caterpillar. Obviously, we talked about this. The caterpillar goes through a complete metamorphosis and becomes a butterfly. So that is a change, not an adaptation, because it's actually part of their life cycle. The change is part of their life cycle. Lovely. Thank you for that. Okay. Very nostalgic there. And Ooh, what about this one? So let me explain this. So if you want to do something, your poster on space and the changes and adaptations in space, one of them that you could talk about is a black hole. So what happens with a star at the end of its life is basically a star is a big, and if you've ever seen The Lion King, Pumbaa was right when he talked about it. A star is a big burning ball of gas. Our sun is a star. Our sun is not even one of the biggest stars. Our sun is a medium-sized star. And what happens is the sun or the stars are happily burning away their gases. They burn, 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 and it has different layers of gases within it. It has a large outer layer of gas which constantly burns at a consistent temperature. There's slightly fluctuations, but it's quite controlled. But then what happens is it runs out of the first gas and it starts to burn the other central gases, which are smaller, until it reaches the central gas, which is a very explosive gas. And when it reaches this final gas, the star will explode. So at the end of its life, a star will explode. Now, that's not something to worry about with our sun because scientists believe the sun is about halfway through its life. The sun has been around for 4.6 billion years. I think it's 4.6. 4.6 billion. You'd have to fact check that. It might be 4.5, although I think the Earth is 4.5 billion years old. I think the sun has been burning for 4.6 billion years. If it's halfway through its life, that means that the sun still has 4.6 billion years left to burn. So nothing to worry about there. He's lagging. I apologize if I'm lagging. Hopefully the internet will sort itself out. But that means the sun has 4.6 billion years left to burn. So nothing to worry about with the explosions of the stars. However, stars do explode and have been exploding all around our universe. Now, if a star is one of the larger stars in our universe, when it explodes, the impact is so powerful that it tears the very fabric of our universe, creating something that scientists don't really quite understand what happens in just yet. When a large star explodes, it creates a black hole. And then everything around that star, even around that fallen, collapsed star, even time, not the concept of time, actual physical space-time is sucked into that black hole. So it starts as a star, just like our sun. Because of the gas running out, it explodes. And if it explodes violently enough, it creates a black hole. Is that a change or an adaptation? Is it changing to suit its environment, adapting? Or is it turning into something else? A change. What's that doing? Absolutely. Change. It's a change. Yeah. And that's another change that you can show. And maybe you could research prior to creating your poster changes that occur in our universe or adaptations that happen in our universe. If you are interested in doing something on space, there are changes and adaptations in space. Research them. This is the one I was excited to tell you about. I don't know if any of you have ever watched Planet Earth, but Planet Earth 2 featured this fish. Does anybody know what type of fish this is? Anybody know what type of fish this is? I have a few guesses. A shark? No, it's not a shark. Hey, we got it pretty quick there. Well done. That is a catfish. That is what a catfish looks like. A pretty creepy looking fish, actually, I think. But this was on Planet Earth 2, and it was very interesting. So here's what happened. Catfish were introduced to an urban river. They were introduced, so they were put into this river because there was an overabundance of a type of fish that was a pest. Yeah. So people introduced the catfish, they put the catfish into this river to eat these other fish. Yeah. And to lower the population. What the humans who put them there didn't understand or realize was this: the catfish have a big appetite. And they didn't just lower the population of these fish, but they ate everything in that river. They ate all their food. They ate all the other fish. So they had no food left. These catfish had no food left because catfish, the big catfish, eat smaller fish. So what they did was this: the catfish learned that when pigeons want to clean their own feathers and wings, they come down to the river and they'll have a drink of the river and they'll use the water to clean their feathers. And when they're cleaning their feathers, oil that's on the feathers gets into the water. And it's an oil that the catfish can detect, which meant the catfish knew when the pigeons were in the water or near the water. And because the catfish had run out of fish to eat, they started to eat the pigeons, jumping out of the water to catch those pigeons and eat them. Now, the catfish, they haven't completely altered. They're still catfish. But the place that they lived ran out of food and they changed their diet and eat birds. Could you imagine? A huge fish jumps out and eats birds. Weird. But is that a change or is that adaptation? What do we think? Okay, we think change. Anybody else? Adaptation. So weird of the cat. It is weird. Change, adaptation. That one's kind of mixed. This one is actually an adaptation. Because what's happened is the animal hasn't changed. It's still the same thing. No change has occurred. But its environment has changed around it. So it has adapted to be able to survive. And actually, you find that a lot of adaptations happen because things want to survive. So what could you design your poster about? Well, animals is a key one because animals change and they adapt, yeah? Animals, for example, we build lots of cities, don't we, across the world, and animals have adapted to be able to live in that city. In fact, for some animals, for some types of birds, the city is great because they can live high up and they can see their prey from high up and they can dive down and capture their prey. Some cities are really great for animals living in, and animals have adapted. Some animals have not been able to adapt to city living and have sadly died because of that. I went to Kosovo today. Can I enter the draw? Everyone who's in the chat and has commented in the chat will be in the draw, so don't you worry about that. Humans, we change throughout our lifetime and we adapt. Think about how we adapt. We adapt to our social situations. If we were trapped on a desert island, maybe that's a poster you could create. What if a human was trapped on a desert island? How would that human have to adapt? Maybe you could talk about evolution and how humans have changed over time, or how animals from the starting point have changed over the time. So humans and animals. Space, we had a look at. You could talk about the space, the changes in space. Maybe you could talk about how we have to adapt when we travel into space. We watched the live lesson this week about Tim Peake, and he was telling us about things that he had to slightly adapt to be okay living at the International Space Station. You could do a poster on states of matter, so liquid, solid, gas, plasma. You could do a poster about electricity, which I've mentioned. You could do a poster on light. So how does light change? What is it like with light, without light? What is light composed of? How does the sun change position throughout the day? How do shadows change throughout the day? You could do that. You could do cooking, which I've already mentioned. In fact, right at the end, look, you can do any area of science, because there are changes and there are adaptations in every area that you can think of in science. Right, let's get to the kind of main event, yeah? Because what I want to just go over, and I'm going to ask the chat to help, is what can you do, what can you add to your poster to make it really, really strong? The features of a good poster. Now let's look at the features. There we go. That's what I was saying. Here's an example poster. We're not going to zoom in on the writing because the writing is all just nonsense. This is just an example. But let's look at the heading. What do you notice about that? Look at the poster. What do you notice about that? What about the subheadings? What do you notice about that? What are these? And what do you think the features of a poster are? Oh, I'm giving them away. What do you think the features of a poster are? Well, let's think about purpose of posters. Really, I think there's a few purposes, but the main ones kind of fall under the same two headings for me. I think you can have posters that inform, and you can have posters that advertise. Posters that tell you something, posters that try and sell you something. And the posters that try and sell you something can be different. They could be about a concert, tickets. They could be about an event. They could be about somebody's bike that they've got for sale. It can be about anything, but they're trying to sell. The ones that inform, again, can be about anything. It could be about a virus. It could be about staying safe in a certain area. But its purpose is to inform. And I think those are the main two purposes. But regardless, how might you design a poster? What might you use? Let's have a look at some of the things that I will be looking for good poster winners. Here we go. Eye-catching colors. They are colorful. They grab an attention. Now think about audience. Bright, jazzy, kind of red, yellow, blue primary colors will interest children. Maybe not adults. Maybe they'll think it's too childish. Think about who your target audience is. You can use parenthesis when you're talking about things, but I would keep your sentences short in a poster. Yeah, font. So when you come to the headings or the subheadings, you want them big so that people can read a poster from far away because they see those posters from far away. Captions and pictures, absolutely. Pictures, because when you see a poster, you're walking down the street. You give it a glance and you notice it. It might only be for a second. So you want that person to be interested. How do you interest them? Big letters, captions, pictures, colors. We've got all that. What else when we dip into it? Yeah, you might put useful websites on that poster. Absolutely. We've said website links, but you might have phone numbers on there as well. A title, headings. You might have persuasion. Absolutely. If you want people to do something, the advert posters would be full of persuasion, like rules of three, like emotive language, like limiting time. This is a limited time offer. You need to get this now, otherwise you'll miss out. That's an advertising thing. Information slightly different. You will present in an information poster facts, but because it is a poster, those facts should be short, clear, and to the point, not going on and on and on and on and on. No one's going to read that unless it's an actual book or an actual text on the matter. For a poster, what you write needs to be short. Yeah, you could use slogans. You could use alliteration. You could use puns. That's very punny. You could use snappy phrases that get stuck in people's head. Short and snappy. I like that. Yes, slogans we've said to get the attention of the reader or to get it stuck in their head. Here's some of the features that I listed. And you can revisit. So you can use big, bold writing. You can use sensational headings. So Spaces all around us, something big and bold and something that grabs your attention. A catchy slogan, which we mentioned using rhyme, alliteration, or a pun. Clear, short bursts of information, not masses and masses. No one's going to read that on a poster. It needs to be short and to the point on a poster. Images, captions. I think we got a lot of what we need to use. So there is nothing left for me to say regarding the posters and our competition other than good luck. We will be choosing 5 winners from our school. Mrs. Jarvis is the one that is going to be running the competition. So she will be looking at your work and she will be choosing which are the best. Now, just before I go today, I just wanted to have a quick chat about Pobble Live. So can we do 1 or 2 pages, Mr. Keeling? Why don't you, if you're thinking that you might do 2 pages on it, why not do it on A3 and ask your teacher for A3? Because then you've got lots of space. Do I bring it to you? You can bring it to me. I'll be passing it on to Mrs. Jarvis. Same with any class. If you bring it in, it will go to Mrs. Jarvis. Don't go. I'm not going just yet. I just need to talk to you a little bit about Pobble Live. So very quickly. Next week will be the final week of Pobble Live for a few weeks. The reason is we are getting closer to SATs, and I will be looking on a Wednesday to do a short after school club in the lead up to our SATs tests. Once the SATs tests are over in the summer term, we will be right back with more episodes of Pobble Live for you. So we're just going to be taking a break for about 4 or 5 weeks so that I can do an after school club and so that we can focus on that. But then we will be right back with Pobble Live. So please do tune in next week, because next week will be the final Pobble Live for a few weeks, okay? And it'll be really good for you to tune in for that one. We'll do a really fun one. And I might do a longer piece of Pobble that you can do through the weeks that we won't be live. I will send out a school spider so that people are aware when we'll be starting back up. And we will do our final Pobble next week. Can we do a leaflet? I'll have a think about what we can do, and we'll bring it up next week. So thank you so much for joining our science-themed Pobble Live this week. I will see you next week for our final Pobble for a little while. And until then, and as ever, keep pobbling, 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 keep pobbling, 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 keep pobbling, 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 Pobble Live! I'll see you next week.